In application of laws of indices, we have many examples. We have example 1, example 2, example 3, like that. So let us begin with example 1. In our example 1, the question says, simplify the following. Part A, we have 3 to power 2 times 3 to power 3. So if you can see this properly, this is multiplication of indices. So when you're multiplying numbers of the same base, you will do what? You add the powers. So in our example 1, we have 3 to the power 2 times 3 to the power 3. So since the bases are the same, we just write one base. Then we add the powers, which is 3 plus 2. 3 plus 2, we get 5, and that is the answer. That's for part A. Then let us go to part B. Part B, we have 3 to the power 4 divided by 3 to the power 2. So if you can see this fraction, it means this is division of indices. So when you are dividing indices, you just subtract the powers. You write the power of the numerator first, then you subtract the power of the denominator, which is the lower one. So in 3 to the power 4 out of 3 to the power 2, this is the same as 3. You write the base only once. After writing the base, then you subtract the powers. By writing the power of the numerator, then you subtract the power of the denominator. So here we have 4 minus 2. Then we get 2. So in this case, the answer is going to be 3 to power 2. Alternatively, for part B, you can as well begin by taking the denominator up so that it also be the numerator. But remember, if the denominator is having a power which is positive, when it is coming up, it changes to negative. So now let us look at it step by step. So the first step, we have 3 to the power 4 divided by 3 to the power 2. So this is the same as 3 to the power 4 multiplied by 1 out of 3 to the power positive 2. So now, if you have a fraction, that fraction you can separate as being 1 out of denominator, then multiplied by the numerator, the way we have indicated it here. Since multiplying A by B is the same as multiplying B by A, so here, which means multiplying 3 to the power 4 by 1 out of this fraction is equal to the multiplication of this one. So arrangement doesn't matter. So here we are proposing to write the numerator first, then you multiply by 1 out of the denominator. Because when we multiply the numerators back and denominators back, we shall get the initial number which was given. So the first step, you separate the numbers. One fraction should be aside, then the numerator should also be the other side. So that the next step, this one we have 3 to the power 4. 3 to the power 4, then multiplied by, now you take this one here, the numerator, the denominator here, you take it to be a numerator. So the sign which is positive will change to be negative. And that is why we have 3 to the power negative 2. Then from here, since the bases are the same, we can multiply the, since the bases are the same and it is multiplication, so we use multiplication, no? This is by adding the powers. Since the bases are the same and they are being multiplied, what we do, we write only one base, then we add the powers. So the first power here is 4. Then when we add negative 2 to it, we shall have 4 plus negative 2. And since negative 2, since here we have two signs, we have plus and minus. What we do, we multiply the two signs so that we can get only one sign. And when we come up here, that is what we are going to do. So 3 to the power. So when we multiply 4 times negative 2, we get, when we multiply positive times negative, we get a negative. That is why negative is here in between. So this one, we shall now have 4 minus 2 as being the power. So that 4 minus 2, you get 2, which is giving us 3 to the power 2. So it still gives the same answer as the first one. The first method here. So let us go to example 3. In our example 3, we have 3 to power 2, everything to power 3. And since the powers are now different, powers are 2. So what we do, we just multiply powers because there is a power inside and power outside. We multiply the powers and we get the product of the powers. And that will be the power of the base. So our solution says 3 to power 2, everything to power 3. So this one is the same as 3 to power 2 times 3. We just multiply the powers. When we have two powers, one inside the bracket, another one outside the bracket, simply we just multiply those powers. So when we multiply 2 times 3, we get 6. So that is why in the next step we have 3 to power 6. So let us also go to part D. Part D we have 2 to power, part D we have 2 times 3, all of them to power 2. So in this kind of arrangement, we know that the power which is outside is supposed to be for each and every number inside. So since we have 3 times 2, everything to power 3, it means this 2 here is the power for each of them, which means 2 here will be to power 2, then 3 here will be to power 2 as well. That will be the answer. So let us go to part E. Part E, we have 2 out of 3, everything to power 3. So since the bracket is covering all of them and the power is outside the bracket, so which means that power is for each and every number inside the bracket. So from here we have 3 out of 2, everything to power 3, which means the same as the numerator to power 3 and denominator to power 3 as well. So that is how we go about with it, according to part E. As far as example 1 for application of indices is concerned. Okay, let us continue to part F, which is still under example 1. Part F, we have 3 to power 3 out of 3 to power 3. So in our solution, we shall have 3 to power 3 out of 3 to power 3. This is the division of indices. What we do is subtract the powers. So we write only one base, which is 3, since the bases are the same. So we write the power of the numerator minus power of denominator. So this will be equal to 3 to power 0, because 3 minus 3 is 0. So any number to power 0 is 1. So which means here also 3 to power 0 will also be 1. Alternatively, we can also separate the fractions, then we use idea for multiplication of indices. So now we have 3 to power 3 out of 3 to power 3 as being an alternative method. So this will be equals to 3 to power 3 then times 1 out of 3 power 3. So it is the numerator times 1 out of denominator. So in the next step, we maintain the 3 to power 3. Then the other one, we take the denominator up. Since here we have 3 to power 3, when we take it up, it will be 3 to power negative 3. So now, since the bases are the same and we are multiplying them, we simply add the powers. So the power of the first one is 3. And when we add the second power, the power is negative 3. So we have 3 plus negative 3. Since there are two signs in between, we multiply them to get only one sign. So let us multiply. Positive times negative, we get negative. That is why we have 3 minus 3, which we shall get 0. So any number to power 0 is 1. That is why 3 to power 0 also, we are also getting 1. So now, let us go to part G. Part G, we have 3 to power negative 2. So this is 3 to power negative 2. In our solution, we begin by writing 3 to power negative 2. Since we want to do away with the negative, so what we do, since we know 3 to the power negative 2 is not having a denominator, so which means the denominator is silent 1, so we shall just bring it down. Bring it down, so this one will be 1 out of 3 to the power 2. So by coming from the numerator to denominator, the sign will just change, and here a negative will not appear. And that is the answer.